Hey, morning everybody. Okay, today we'll touch base with the magnetic effect of current. Okay, so far we have talked about how to make a magnet. So we literally need a magnet to have magnetic effect, and we also talk about how do we actually create a magnet or imbue the magnetism. Okay, how do we remove the magnetism from the magnet? And we also look at the materials that are suitable for making a magnet. For example, soft iron core, soft iron, or we could be looking for steel. Okay, whereby iron is easy to magnetize and easy to demagnetize. Steel is hard to magnetize, hard to demagnetize. So these are the material that we look at. So which inherently we are looking at the fact that when you look at you need magnetism, you need a magnet. Okay, but actually it doesn't have to be that way. Okay, there's another way of creating magnetic field without having a magnet, and that itself is what we mean by the magnetic effect of current, whereby I can actually use current to mimic the magnetic effect of a magnet. Okay, so I don't need a magnet to have a magnetic effect in this sense. Okay, but here how it go. Okay, basically what we have is that you have a current. Okay, and you find that if you look at it in terms of the magnetic field lines, you investigate using the same method. For example, you put a compass at the cardboard here. Okay, you put a compass, you'll find that the compass will actually point in a certain direction, and they'll point in a certain direction like what you did for your to identify the magnetic field lines. And you'll find that the strange effect is that the magnetic effect, there will be what we call concentric circle happening on the cardboard. And this concentric circle has certain effect. It has certain similarities to magnetic effect, whereby the circles will never crisscross each other, and the circles are actually marked out by the north pole of the magnet. So it will actually point in a certain directions. Okay, and like the final one we have is that the stronger the magnet, the closer is the line, the stronger is the magnetic field lines. Okay, and after that you'll find that there are various operations, or there are various um, examples whereby we actually illustrate that this is actually the magnetism effect of a current. Okay, and in a short is that I can actually have magnetism using a current without having a magnet itself. Okay, so this is what we mean by the magnetic effect. Okay, and you find that the magnetic effect in the magnet, there's north pole and south pole. Within the magnetic field lines, it goes from the north pole to the south pole in a certain directions. And similarly, if you look at the magnetic effect created by a current, you'll find that the field lines, it does possess certain characteristics of north and south. It has the current does the magnetic field line created by current does flow in different directions at different orientation. For example, if I have the current, okay, flowing out of the paper, okay, means towards you, okay, you'll find that the field line will be in a certain direction, what we know as anti-clockwise. But if the current is flowing into the paper, okay, what we call away from you into the paper, into the screen, you'll find that the field line will be in another direction, will be clockwise. So you find that if I reverse the direction of the current, I actually reverse the field lines. Very similarly to it's similar to like what we see in the magnet of a north and south pole. Okay, so in a nutshell, that there's actually these two bipole thing in a current, in the field lines created by the current itself. And how do we decide on this field line? How do we have this field line? Okay, now similarly, okay, before I show you how to decide the current direction, clockwise or anti-clockwise, one thing to take note is that similar to magnetic field lines, the closer the field lines, the stronger is the magnet. So in current, magnetic field line produced by current, same thing, the stronger the current, you'll find that the closer is the field line. Okay, the closer is the field line. So which means that this will be stronger, the field line here will be stronger, and the field line here will be weaker. Okay, in the sense that the stronger the current, the stronger is the magnetic field lines. The stronger is the magnetic effect. And how do I represent it in the magnetic effect? I will have field lines closer to each other. Okay, now if you look at the flat coil, okay, now you look at the coil here. Now for flat coil, okay, before I move on to the flat coil, okay, one thing I want to highlight to you guys is how do we derive the field line first, okay, before I go into further example, because I received comments saying that people asking to how do I create this fill line? How do I create this fill line pattern first? Okay, so before I move on, okay, let me run through how do we create this fill line first. How do we get this fill line? Now, the current here, the idea, the method towards getting the fill line here, let me take a look first. Okay, let me get eraser first. Okay, the idea of getting the fill line here is to use Maxwell the Maxwell right hand grip rule. Okay, now how do you use Maxwell right hand grip rule here? Okay, now using your Maxwell, this pattern is actually derived from how do we use it? We use it in Maxwell right hand. Okay, so what we are trying to do now is this. Okay, you have to use the right hand. So your thumb in the whole hand. Okay, so you have your thumb in Maxwell right hand grip rule. There's two versions of it. One version is for straight line cable. For example, the one that you're seeing on the screen now. Okay, so now let's take a look. Okay, okay. Now if you look at the screen now, Maxwell right hand grip rule, the first version is for a straight line wire. So if I have a straight line cable like this, okay, the current is flowing upwards. So my thumb will represent the current. Yeah, my thumb will represent the current. For straight line cable, Maxwell version number 1, for a straight line cable, the thumb will represent the current direction. So the current direction now is going up. So what you're going to do is you're going to grasp, okay? You're going to try to grab the wire like that. So you'll find that your finger will curve from right to left. Okay, and if you look at the paper, if you look at it from the top view, you'll find that it will flow in a clockwise manner. Okay, now let's look at another example. Okay, now how do we get the direction? So now we look at the first one. Okay, now the dot represent the current is coming out. So imagine this is the paper, you're looking at the paper, so the current is going towards you. So if it's a straight line cable, your thumb represent the wire, okay, or represent the current. So which means the current is coming out towards you. So my thumb will be pointing towards you. Okay. So which means if you're having your thumb, okay, so if you're having your thumb will pointing towards you. Okay. Okay. So like what I'm doing now, okay, your thumb is pointing towards you. The current is flowing out of the screen. Out of the screen. Okay, so the thumb will be the current. Then what you do, you're going to curl your fingers. You curl your finger, you will in this motion. Okay, in curl this motion, okay, you will find that this finger will represent the few lines. So you will curl what we call in the anti-clockwise motion. Okay, this is how we use Maxwell right hand grip rule version 1. For let's say, for example, now if you repeat, the X represent the current is flowing away from you. Okay, so how do I get the few line direction? Same thing, away from you. So if with the right hand thumb, current is flowing away from you. Okay, so time away from you. So what away from you means away from you, away from you. You are the audience, so away from you. So after that, the thumb will be away from you. I grab my finger, grip my finger. You'll find it will flow in this direction. You will have this orientation, which is clockwise. So this finger will tell you the direction of the few lines. So this will be telling you that the few lines will be clockwise. And this is how I actually uses right hand grip rule to actually tell the direction of the few lines from the current itself. Okay. Now, same thing, but now you have what we call a solenoid. Solenoid, same thing, you have this field pattern here. Okay, the field pattern is similarly, okay, you have one direction. What you are going to do now is you are going to do it separately. Okay, so you are going to do for direction number, for side number 1 is the current going into the field line, into the page at number 1. So you have this particular field orientation. At number 2 location, you find that the current is flowing out of the paper. And if you use a Maxwell grip rule, out of the paper, you grip, okay, you'll find the few lines is this direction. So now what you're going to do, you are going to combine number 1 and number 2 together because it's a solenoid. Okay, so you have a few pattern number 1 here and number 2 here. So what you're going to do, you're going to place the few lines together, and together you have a combined few lines that looks like this. Okay, you have a combined few lines that look like this. Okay, and this is the few lines for what we mean by a flat coin. Okay, and similarly, if you turn the coin, you'll find that you have what we call a solenoid this way. Okay, this is like many coins. Okay, many turns of coins. Okay, if you combine these turns of coins, you have a few lines that is this way. Okay, and you'll be surprised to say that Okay, the field, if you have many field lines, or what you call, you have many coils, or what you call many solenoid, the field line that you produce, okay, will be actually mimicking the field line of a magnetic field line, mimicking the magnetic field line of a magnet. Okay, now how do we look at this curve pattern here? Okay, now here you have to be careful. So now let's take a look. So now how do I get this solenoid field line using Maxwell grip rule? This is why we talk about Maxwell grip rule version number 2. Okay, grip rule has 2 versions, one for straight line cable and one for solenoid. So let's take a look. Okay, now for solenoid version, okay, Maxwell grip rules for solenoid version 2. Okay, your fingers, okay, will represent the current now. Okay, your finger will represent current now. Okay, your thumb will represent the north pole. Okay, so there's a slight difference in the fingerings. Okay, so for version number 2, the hand will be the current. So if you look at the solenoid, you find that the current is actually going from upwards, up, and in behind you going downward, coming up again. Okay, coming up. So you find that if you follow the direction of the current will be coming out, upwards, going in, downwards. So you'll find that the current will be coming out of the coil itself. Okay, so this will be where the thing is, your current is flowing. So what you do is your fingers is going to be behaving like a current. So your fingers will be following the current direction. So the current is upwards, okay, flowing upwards. Okay, if you look at the screen, you look at your screen, your finger will be flowing upwards. You remember, you must use your right hand, right hand. Okay, upwards. Okay, you curl this way, and after what you do, you let go your thumb. You curl, you let go your thumb. Where the thumb points, that will be the north pole. So my north pole will be here because my thumb point there, and automatically south pole will be on the other end. So if you look at this carefully, you'll find that, okay, the north and south pole actually mimics an actual magnet of north pole and south pole. Okay, and the field line actually is same thing. It points from left, it ends with right. So it's coming out from the north pole and going back to the south pole. So you find that these two patterns, they are identical. So which means what we are saying is that I have enough evidence to say that the current, the field created by a current is actually a magnetic field lines, because it actually is identical to a magnetic field line produced by a magnet itself. Okay, so this is where the evidence tells us that it is a magnetic field lines by a current. And same thing, okay, to increase the field lines, there are 2 things they can do. You can increase the number of current, the amount of current, and you can increase the number of turns of coil. Okay, so between the more coils you have here, the stronger is the magnetic field lines. Okay, and similarly, okay, the field lines at the center is actually the strongest for solenoids. Okay, this is what we mean by your pole here. You done by right hand grip rule. Okay, Maxwell right hand grip rule. Remember, there's 2 versions. The freest version we talk about is a straight line cable, whereby the thumb represent the current, finger represent the field lines. Version number 2, solenoid. The finger represent the current, the thumb represent the north pole. So there are 2 versions. So students, you need to know which version you are using. If it's a straight line cable, you must use version 1. Solenoid, you must use version 2. Okay, to get the north pole, all these things. Okay, same thing. These are the possible effects of using or increasing a magnetic field lines. Is the same as before. Increasing the number of current, increase the number of turns, and placing a soft iron core. Why I use a soft iron core? Okay, because I have induced magnetism. I can induce magnetism on the iron core. So literally, I have so-called an additional magnet to help me increase my strength of magnetism. Okay, some common applications you have is your circuit breaker that you learned in the previous topic on electricity. Okay, it uses electromagnet. Okay, then this is how we look at it. Okay, in your textbook, you have quite a good example, fair share of examples on circuit breaker, and there are a lot of applications. Okay, you have to get accustomed to it. But here, I will not dwell too on the details. If you need to, okay, refer back to your notes that you are your textbook or even the online version. Okay, to get the understanding of this. But important thing, I'll highlight some of the important stuff is in the circuit breaker, you'll find that the main thing is this solenoids. Okay, the idea of the solenoid is when the current flow through, it will become an electromagnet. It will become electromagnet once with temporary magnetism effect. And what it does is it will attract this latch. So once I attract this latch down, so in the sense of excess current, excessive current. So what it does now is excessive current. You take a look. Okay, excessive current. My solenoid here, my electromagnet will be strong enough to attract this latch. And because of that, my safety bar will be ejected and there will be a gap here. And because of this gap, you'll find that the circuit now is broken and the excessive current is actually being stopped now. And this is what I mean by circuit breaker. Okay, your circuit breaker does make use of magnetic effect to release the spring. And when I release the spring, okay, there is a hole or there is an interruption. And as a result, I cause the circuit to be broken and your electricity, your excessive current is stopped in this case. Okay, here the things to highlight. Okay, remember that we have two versions of Maxwell. Maxwell right hand grid rule. There's a one version for straight line cable. There's a version for coils, or sometimes we call this solenoids. Okay, so students, you have to be careful of what cable are you using, whether it's a cable or is it a coil. And if you need to use Maxwell, you must know which version of it you are using, whether it's version 1 or is it version 2. Okay, then after we talk about the applications. Okay, applications, okay, it uses magnetic field lines. It uses the idea of electromagnetic, whereby I can turn on and off the electromagnetism. Okay, with that, okay, I'll end this particular section here. Okay, any questions, you just leave your question at the comments bar, and just like I'll get back to you ASAP. If not, okay, remember to go back or rewind this video or rewatch this video on the important things of Maxwell or the using of getting the magnetic effects from the current. Okay, if not, you can refer to your notes. Any questions, you can leave a question or you can just email me the questions. I will get back to you ASAP. Okay, if not, okay, thank you very much, everybody. And this will be the end of the presentation. Bye-bye.